Assalamu alaikum. In this chapter, we will learn about Karnaugh map. In the last chapter, as we have learned that how we will use the Boolean functions using the Boolean theorems. Now we will learn that how we will simplify the same Boolean functions using in Karnaugh map. It is other method which we will use for solving the same Boolean functions, but this method is known as Karnaugh map, and in this method we will get a table as a result, right? And then we will solve the equation by using this table. And now the question arises that how many cells will be there in the table which is the result of the Karnaugh map. We have the formula 2 raised to power n cells, and in this 2 raised to power n is the number of variables which are used in the equation, right? So if there are two variables in the equation, so there will be 2 raised to power 2 is equal to 4. So 4 cells will be there in the resultant table. We will learn these tables for variables, different variables in the next slides, right? Now this is the line that the adjacent cells are differed only in single bit position. These cells, we are talking about the cells which are in the table, as we have studied that we will get a table as a result of Karnaugh map. So this resultant adjacent cells will be differed only by a single bit position, right? This is a very important point, and we will discuss this important point in further detail in the next slides, right? First of all, we will consider that K-maps or Karnaugh maps are used for 2 to 5 variables. We will study 2 to 4 variables in this course, right? So first of all, we will study that how Karnaugh map is used or it is made for 2 variables. So 2 variables K-map is as follows. Let's say we have 2 variables y and z, right? So we will write y and z here, or a or b, right? We will write a here and b here, right? So first of all, what we will do, we will write the possible bits for the y or a. So we will write 0 and then 1. This is the possible bits for y. Similarly, we will write possible bits for z, which are 0 and 1. And we will get 0 0 for this cell, 0 1 for this cell, 1 0 for this cell, and 1 1 for this cell. As we are finding sum of products, so we have min terms, as we have studied in the last lecture, that min terms will be 1 for the expression, right? So, and min terms will be denoted by small m. So small m is, we will write small m here and m0, m1, m2 and m3 for each cell, right? So first of all, what we will do, I'll solve here for your comfort that if we have 2 variables which are, we'll say, let's say y, we are taking the same y and z, we will write here y and z, and as we have done that there are 2 variables, so 2 raised to power 2 is equal to 4, right? So there will be 4 cells. So what we will do, we will make 4 cells here, right? 4 cells here, and we will write the possible bits for y, which is 0 and 1, and here similarly for z we will write 0 and 1 here. As we know that we have denoted that 0 will be noted by y complement also, as we have studied in min terms, and 1 can be noted by y, right? So we can write y here also, similarly z complement and z here, right? We can do in different tables also, and we can do in one table also. I am doing it in one table for your convenience, right? So what we will find, 0 0 here, 0 0 here, right? And y complement and z complement. So I'll write here y complement and z complement, right? And the decimal value for 0, 0 is 0. As we know, the decimal value is 0, and we will note this by min term m naught, right? Okay. Similarly, we will do this for this cell also. 0, 1, we will write 0, 1, right? And y complement z, y complement z, right? And what is decimal value for 0, 1? 1, as we have studied in the previous chapters. You can do by using the conversion, as we have studied that we can do the conversion by going from the binary to decimal values, right? Similarly, we have m1, as we have studied like m naught. Now what we will do, 1, 0, 1, 0, and y z complement. And what is the decimal value for 1, 0? 2. It will be m 2. And similarly, we have 1, 1, yz, yz, and the decimal value for this is 3, and we will get m3, right? m3. Okay. So this is the Karnaugh map for two variable, which is y, z. Now we have the possibility of grouping these variables also, which is there is only one possibility of grouping four adjacent minterms, right? And we have the possibility, we can do here as well, m0 and m1, we can group the variables like m0 and m1. Similarly, m2 and m3, right? And I'll pick the color from here, and m0 and m2, which is this cell, right? m0 and m2, and the other cell is m1 and m3, as you are seeing here, m1 and m3. So we will group the variables by using this strategy, and by these groups we will find the equation later in the questions, right? And we can also use this method or this method, but I will recommend that using one method will be easy for you. So we will use this method in the next slides. This is a K-map for two variables, right? Which is A, B, B complement, B, right? It is the same like we have done here, right? It is for YZ and this is for AB. So it is sum of product, and we are learning here sum of product. We will learn product of sum later. And it is the same like we have done in the paint, right? So you will easily learn that what it is going to explain. Okay, now we will learn that what is Karnaugh map and gray code sequence, right? If we will study three variables, first of all we will study three variables, and then we will again jump on this slide again, okay? Now we will study what is three variable K-map. So we will write x here and yz here, right? And this is 0, 1, possible solutions of or possible bits of x, and yz, it is 0, 0, 0, 1, 1, 0, 1, 1. But as you have seen that it is 0, 0, 0, 1, 1, 1 and then 1, 0. 1, 0 is not written here. Why? Why 1, 0 is not written here? The answer of this lies in this slide, right? Because we are seeing here in this slide that the adjacent cells are differed only in single bit position. But if we write 1, 0 here, then it will 2 bits will be changed here, which is not required in the Karnaugh map, right? So we will learn that the sequence of numbers across the top of the map, it is not in the binary sequence, which would be 00011011. It is 00011110, which is gray code sequence, right? It is required. This is the scenario which is required for the Karnaugh map, right? As we will see, I'll write for you. We'll make 8 cells. Why 8 cells? Because there are 3 variables and 2 raised to power 3 is 8, right? So we have, it is, right? Okay. It is A, B and C, right? And we will write the sequence here, which is possible bits are 0 and 1, right? It is 0, 0, right? It is 0, 1, right? Now, what is changed? 0, 0, this, okay, I'll write and then I'll tell you, right? And I'll write 1, 0 here. Let's say we will write 1, 0 here, which is a binary sequence, right? So I'll change the color for you people. Look, this cell, this bit and this bit are same. It is changed only by single position. If we will write 1, 0, then in this 0 is changed to 1 and 1 is changed to 0, which is not required because 2 bits will be changed here. So it will not be the solution, and we will write 1, 1 here, because in this scenario, this one and this one are similar, but only bit changed is 0 and 1. So we will write 1, 1 here and 1, 0 here, right? So this is known as gray bit sequence, which is required for the whole scenario of the Karnaugh map, right? Now let's come again for the in the Karnaugh map for 3 variables, as we have seen here that it is the same like we have studied there, that what we will do 0, 0, 0. It is the decimal value for is 0, right? 0, 0, 0, 1, 0, 0, 1. Decimal value for is 1, 0, 1, 1. The decimal value for this is, as you know, the decimal value for this is 3, and we will note this by M3, right? M3. Similarly by M1 and M0, and for each and every cell we will write this. Decimal value for this is 0, 1, 0 for and the decimal value for this is 2, right? And you know that we will write A complement here, and B complement, C complement, and similarly for the other cells also. And we will write A complement, B complement, C complement, right? And as we see that here in this situation, we have M0 here also, right? It is M0 here also, M1, M3, M2, as we have seen here, right? Now we will see the value for this is 1, 0, 0, and the decimal value for this is 4, right? As you know, this is 1, 0, 1. The decimal value for this is 5. It is 1, 1, 1, so it is 1, 1, 1, and the decimal value for this is not 6, but it is 7, right? And the last is 1, 1, 0, and the decimal value for this is 6. So we will write M6 here, M7, M5, and M4. Like it is explained, M4, M5, M7, and X6. Now what we will see, we will look that how we have, what are the possible combinations of adjacent cells, right? So we will see that the possible combination of adjacent cells are, look, it is M0, M1, M3, M2. The whole we have taken this, right? And the other one also, right? Okay, then it is M4, M5, M7, M6. this one, then M0, M1, M4, M5, right? Wait, what is this? M0, M1, M4, M5. This one we have taken, this one, look, this one and this one, right? Then we have M1, M3, M5, M7, which is M1, M3, M5, M7. It is this one, right? M1, M3, M7, then M3, M2, M7, M6, right? And the last is, I will change the color for you, this cell, right? This cell and this cell, right? So they are the possible combinations for 4 adjacent minterms. Similarly, we can also make 2 adjacent minterms combination, which will be these two, then these two, right? And then last is these two, and then you will also do it vertically, right? Now let's look for the case of 4 variable K-map. As we know that 2 raised to power 4 is 16, so you'll get 4 adjacent cells, right? And there will be Wx, 2 variables here and 2 variables here. So we will write, it is the different case as we have seen in 2 and 3 variable, that 1 bit is here. So we have 0 and 1, but here there will be 00, 001, 1110 and 1110, the same as we have seen in this top row. We will do it vertically as well, right? So the possible value will be similarly as we have done in for the 3 variable, that 000 is 0, and similarly 0001 and the decimal will be 1, 00011 and the decimal value will be M3, 0010 and the decimal will be M2, right? And it is the same for as we have done for the 3 variable, right? Now what we will see, 11100 and the decimal value for this is 12 and we will get M12. Similarly, we have 1101 and the decimal value for this is M13. Similarly, we will do it for all the cells of 4 variables. If you know the rules, then you can easily do the equations which we will do in the next lecture, right? So I hope you have understood this Karnaugh map easily. Thank you so much for watching the lecture.